Hi everybody, this is going to be for CP Algebra 2 or Algebra 1, and we're talking about Chapter 8 for second semester. Let's go ahead and do our odd answers. Okay, so we're on number 12. If I can get there. Okay. So we have this graph over here. So what would, on number 1, if I were to be subtracting 3, that means the whole thing is going to shift left 3. So I'm going to go from here. I'm going to go 1, 2, 3, put a dot, and it looks like a pattern graph, right 1, left 1, up 1. So that was what that one had done. That one will actually shift it down, but we're not doing that one. This one has 2 shifts. It'll shift left 2 because that's grouped, and up 3. So left 2 and up 3. And it's still pattern graphs is right 1, left 1, up 1. So that had a little bit of a little different. And then number 5, we want the function at negative x. I would ask your teacher about this one because this one's going to be kind of hard to see, which it just means that the graph flips over the y-axis, so that actually is the exact same graph right there. So it doesn't do anything. It's hard to see if it's symmetric about the y-axis if it flips over. So it looks like the exact same thing. I think other graphs will help us with that later. Okay, number 7, we have a graph that's already done some shifting. So with A, that means, hey, I just want to move the whole thing up 2. And look, it did go right 1, up 1 still. So that's letter A. This one, the whole thing flips over. So now we're going to be able to see this. This is going to come over to here. So do you see how it flipped over the y-axis? That's what it was doing. And then this one here is going to shift left 3. So I'm going to go left 3, 1, 2, 3, and up 4. 1, 2, 3, 4. And it's still pattern graphs with the right 1, up 1. Number 8, you can do on your own. Number 9, good, okay. So this is actually an exponential graph, but everything still works the same way with the shifting, which is great. So we have our normal graph. This one says, hey, shift me up 2. So I'm going to go from here. I'm going to go up 1, 2. And it's still going to have an asymptote up 2. So now this was our x-axis, what's called an asymptote. We're not going to cross it. So now this is what this one's going to do. This one flips the whole thing over. So it's still going to have that as my asymptote, but it's actually B is going to look like this. So it flipped it over the y-axis. And so that's letter B. Letter C, from our original, we're going to shift right 2 because it was minus and up 1. So we're going to come here. So remember my asymptote is now going to look like this. And that's what that graph looks like. Number 11 looks like we want to talk about what's the shifting that took place. So this was my original graph, this blue one here. Okay, so what did I do? I went over 1, 2. So that means I'm going to have f at x minus 2 because it's opposite if I shift right. And then it went up 1, 2, 3, 4. So I have a plus 4. So that's what that graph had done. Okay, we're in standard form. Find the factored form of the quadratic, give the x-intercept. So we want to start factoring this. Okay, so I'm going to put 3x and I'm going to put x. And then we have to kind of think, okay, this is the grouping method. So I want the factors of negative 45 that add to 12. So you know I have alternating signs. And And so the factors of 45 are 1 and 45, 3 and 15. That's totally going to work. Yes, you also have 5 and 9, but 3 and 15 are going to work. Which one of those would be positive? It would be a positive 15, so I'm going to go 3x squared plus 15x minus 3x minus 15. Now I'm grouping it, so let's take a look at this. I can factor a 3x out, and that leaves me an x plus 5. And here, I need to make sure I factor that negative out, and x plus 5. So now I have 3x minus 3. Oh shoot, and then x plus 5. Being that this has a greatest common factor, this one actually comes out to this as an answer. This is not 12's answer, cross that out. 3, and then x minus 1, and then x plus 5. I could have factored that 3 out in the beginning, but I didn't see it right away. I apologize, so it factored out nicely. Give an equation in factored form. Give the y and x-intercept, or give the y and the vertex for each. Okay, so if I want to find the y-intercept on number 15, the y-intercept, remember, y-intercept doesn't go right or left at all, so I have plugged in a 0 in for x. So 0 plus 1 is 1. I still have that 3 out front. And then 0 plus 5 is 5. So it looks like if I multiply 3 times 1 times 5, I get 0, 15. And then the vertex, well, the vertex is going to happen. I have negative 1, or so I have negative 5, negative 4, negative 3, negative 2, negative 1, 0. So between these 2 points, the vertex is going to happen, which that looks like negative 2, negative 3. And I'll take negative 3 and plug it in from x. So I get negative, so I have 3 still up front. Negative 3 plus 1 is negative 2. Negative 3 plus 5 is 2. And that's going to give me a negative 12. So that's my vertex. Number 17, it says give the vertex, y-intercept, and x-intercepts. Let's take care of the x-intercepts first. So I'll set each of these equal to 0. Don't worry about that. So x equals 1. So 1 comma 0 is an x-intercept called a root. And then I'll take x plus 7, set that equal to 0. So subtract 7. And so then I get negative 7 comma 0 is another root. Okay, so those are my x-intercepts. My y-intercept, remember, I'm going to plug 0 in for my x value. So 0 minus 1 is negative 1. 0 plus 7 is 7. So negative 1 times 7 is negative 7. And then we need to find the vertex. So the vertex is going to, think about this, where my roots are. I have 1 here. Now let's go negative 7 here, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0, and then 1. Okay, so I have my roots here and here. So let's go in halfway. So going here, going 1, going 1, going 1, going 1, going 1. Looks like right there. So negative 6, 5, 4, 3. So that's negative 3. So my vertex is going to be at negative 3 comma something. So if I take negative 3 and plug it in, I get negative 3 plus 1 is negative 4. And negative 3 plus 7 is 4. So it looks like I have a vertex at negative 3, negative 16. Sorry about that. And then number 19, we want to write the quadratic equation that has a vertex of 1, negative 8, and passes through 3, comma 8. So we have to remember my vertex form equation looks like this, where h and k are the vertex. Okay, so the vertex is at h and k, and then this is an x and y value. The only value I'll have to solve for is the a right there. So I'm going to get 8 equals a, I don't know, x is 3, minus h, which is 1 squared, plus k, so plus negative 8 or minus 8. 3 minus 1 is 2, 2 squared is 4, so I get 4a minus 8 equals 8. Add 8 to the other side, so I get 16 equals 4a. So a is going to be equal to 4. So now I'm going to plug in for my a, my h, and my k, and that'll give me my equation. So y equals 4, x minus 1 quantity squared minus 8. That's your vertex form. I think that might be it on this page.